Hi guys, today we're going to be taking notes through this video. We're going to be specifically starting with our module on volume. So to start, what I want to make sure that you have is your volume divider, your vocabulary page, and then you should also have the very first note taker of the module. What I would like for you guys to do right now is pause the video, take a moment to glue all this stuff in. If you need to ask the sub for a copy of any one of these items, please feel free to do that. And then go ahead and continue the video so that you can follow along. At this point, everything should be glued in. What I'd like for you guys to do is just make sure you have your page numbers on each of your pages. I have in the notebook that I'm working on, my divider is page 107. Depending on which class period you're in, this might be 110, it might be 105, somewhere around 107. Make sure it follows your notebook though. And then do know that this is the page that follows the distance between 2 points note taker that we finished module 12 with. So you have your distance between 2 points, practice, notes and practice. We have a blank page, then you have your divider, your vocabulary, and then the notes. So if you have the same number pages as I do, volume of cylinders on 110 is going to be the first page or first thing in the table of contents for module 13. So module 13 is all about volume, and specifically it's volume of shapes that have some sort of circle embedded within them. So you'll see as we move through module 13, we're going to be finding volumes of cylinders, cones, and spheres. Today specifically we're going to focus on a cylinder. Now, before we even get started, I want to just quickly review what is a cylinder. How do I identify a cylinder? What are the characteristics of a cylinder? All of you probably have a glue stick in front of you or in your bag next to you or somewhere. This is a really good example of a cylinder. It is a shape that has a circle on one side and a circle on another. We call those the bases of the shape. And then it's got this, if I were to unfold it, this rectangular piece in the middle. We're going to talk about how do I find the volume of a cylinder using a very specific formula today. Just to review, a couple of things that you're going to need to know when I am talking about cylinders is to find the is about circles, right? We learned about circles last year, but sometimes the formulas or the terminologies are hard to remember. So the first thing I want to talk about is in a circle, there's a couple of ways to measure a circle. One way is to measure it from the center of the circle to the outside of the circle. We call that the radius. Another way to measure the circle would be all the way across, so crossing through the center. We call that the diameter. So sometimes when I am working with problems that have to do with circles, you might be given the radius, you might work with the diameter. It might give you both, I don't know. You just have to know the difference between the two. Now the radius is always going to be half the diameter because it's halfway across the circle. And vice versa, the diameter is 2 times the radius, so it's like 2 radii. Other things that you might want to know is how do you find the area of a circle, which actually you're for sure going to have to know. The area of a circle is always going to be pi times the radius squared. And pi is always represented mathematically as 3.14. While it is irrational, it goes on and on and on forever, we're only going to be using 3.14 as pi. Okay? And you'll see that as we go through these practice problems, they even say use 3.14 for pi. Now that we've kind of did a little review of circles, we're going to go ahead and talk about how you find the volume of a cylinder. Cylinders, again, is a shape with a circle on either side for its base. There's 2 different ways to find the volume of a cylinder, but ultimately they're exactly the same. So I'm going to actually just go through using the second formula that's given to you. Volume equals pi r squared, and you might notice that's exactly the same as the area of a circle times the height. Okay? That's why this is exactly the same. B is area of the base or area of the circle. They're the same exact thing. I like this one because it makes sure that I don't miss any piece of finding the area of that circle. The height in this case is not always going to be like how far off of the ground the circle is. Sometimes, depending on how you are positioning your cylinder, it could be lying flat, and the height is quite short. If I'm looking at a glue stick, the height would only be across the circle, right? Sometimes if I stand it upright, my height is much higher. In this case, this height will always be the distance between the two bases, the distance between the circles. So what I would like for you guys to do is just to remind yourself, height in this case is distance between bases. Okay? Then I just multiply all that stuff together, I get the volume. So let's go ahead and see what that looks like with a particular problem. Example 1 says, find the volume. I'm going to zoom in here so you can guys see a little bit better. Find the volume of the cylinder. Round your answer to the nearest tenth if necessary. So what I'm going to do is I'm going to use the volume formula here and what's given to me in this diagram to find the volume. First, I'm going to just label what I have. The first thing that is given to me is the distance all the way across that circular base. Remember, like we said earlier, if it goes all the way across the base, that's the diameter. So in this case, the diameter is 4 inches. You'll notice I don't have diameter in my formula, so we're going to just real quick convert that to figure out what the radius. Remember, radius is half of the diameter. So if our diameter is 4, half of that would be 2. Okay? The last thing that I'm going to need to know here is the height. And again, the height is the distance between the two bases. So if I have these two circular bases here, how far apart are they? You can see it labeled right here. The height is 7 inches. Now that I have all those pieces, all I have to do is plug it into my formula. So it's like a super easy substitution. Unlike the substitution method for when we're solving for systems. This is just substituting one for one. So V, volume, that's what we're going to try to find. I'm going to leave that because we don't know what the volume is. I know that pi is 3.14, so I'm going to substitute 3.14 in for pi. R, that's our radius we found is 2 squared, and then times the height is h. Notice I'm multiplying. That's because all of these terms are right next to each other. It is a multiplication problem. Next, what I'm going to do is I'm going to simplify. I do have to consider order of operations here. Oh, I put h for height, but I know what h is. In this case, it's 7. Order of operations says that out of all of the things that are happening here, I've got multiplication, I've got exponents. I'm going to do the exponent first. So if I'm going to do my exponent first, this is 2 squared. That's 2 times 2. I'll rewrite this as 3.14 times 4 times 7. So I'm not going to do anything else to the rest of the problem. I'm just focusing on that part of it. Now this is a simple multiplication problem. I'm going to plug into my calculator 3.14 times 4 times 7. And when I do that, I get 3.14 times 4 times 7. I get 87 and 92 hundredths. Now if I look at my calculator, it says round to the nearest tenth, so I don't actually have to put all the digits that are given to me here. I'm just going to go to the tenths place. I'll look at my hundredths place to help me round. Oops. To help me round, but ultimately I don't have to do anything because that hundredths place is a 2. It's 87 and 9/10. Last thing I need to do is make sure I have the correct units. Since we're talking volume, I'll use this inches, but volume is in 3 dimensions, so we're actually cubing the units. So the volume of this particular cylinder is 87 and 9/10 cubic inches, or inches cubed. Again, if you want to pause and go back if you missed something or you want some clarification, please feel free to do that with this video. I'm going to move on to example number 2. This one does not have a diagram, but it does explain what it is. Many times if you are approaching a problem like this, you can draw a diagram yourself so that you understand what it is. You don't have to. What I would do in this case, instead of drawing a diagram, is I'm going to read through it and I'm just going to list the information given, kind of like I did here. Then with that information, I'll be able to use the volume formula. So the question says, find the volume of a cylinder that has a radius of 2 centimeters. Okay, so automatically that's the first piece of information I'm going to write. Radius, or R, equals 2 centimeters. And a height of 2.5 centimeters. So I'm just going to go height equals 2.5 centimeters. Round your answer to the nearest tenth if necessary. I have everything I need in order to find the volume using that volume formula. Because remember, in the volume formula, I need the radius and I need the height. So let's go ahead and plug it into the formula. So volume equals, I know pi is 3.14. The radius in this case, it's given to me, is 2. And the height is given to me as 2.5. So I've got pi times the radius squared times the height. Just like the last time, we're going to use order of operations. We're going to square the radius first, leaving me with 3.14 times 4 times 2.5. And last but not least, all I have to do is just plug it into my calculator. 3.14 times 4 times 2.5, which gives me 31.4. It says round to the nearest tenth. I don't have to because it only goes to the tenth place, so I know the volume is 31 4/10. My unit, centimeters cubed. And we're done. Now, example 3 is a little bit different. First 2, we were trying to find the volume. If you look at example 3, it's asking us to find the height of the cylinder, given that the volume is 125.6 cubic inches. It also has a radius of 2 inches. So we're going to be doing a little bit of algebra here. Rather than just plugging and multiplying, we do have to manipulate the problem a little bit differently. So first, just like the rest of the problems, I'm going to start by listing the information that's given. If we're finding the height of a cylinder that has the volume of 125 6/10 inches, I know V, or volume, is 125.6 cubic inches. It also gives me that the radius is 2 inches, so I know R in this case is 2 inches. Again, we're going to be using that same formula, V equals pi R squared H. This time, however, we're going to be plugging in different things because I have a volume this time without the height. So what it looks like is I'm going to plug 125.6 in for V. I'm going to make it equal pi, which is 3.14, times 2 squared, that's your radius squared, times the height. And I'm going to leave height as h because I don't know what that is. I then am going to simplify this side by multiplying all of this out. I'll start again with my radius, 2 squared. In this case, I know that's 4. So I'm going to multiply 3.14 times 4 to simplify. That gives me 12 56/100ths, and we're going to multiply it by h. On the other side of the equation, we're going to leave it as 125.6. And then finally, all I have to do is divide by this 12.56 on both sides to get height by itself, which would essentially be solving for the height. Now, if I do 125.6 divided by 12.56, I get 10, which means that the height is 10 and our unit is inches. I'm going to stop there, and I want you guys to try example 4 on your own before you leave today. If you need to rewind, please rewind and rewatch the video as you need. I'll see you on Monday.